Hey everyone, this is just a quick video. Well, it probably won't end up being quick, but it's a kind of a one-off video about something which will probably only be of interest to programmers. So if you're not a programmer, you can probably just click off the video now because I'm pretty sure this is not going to interest you very much. But for people who are interested in programming, especially kind of older ways of programming that used to be done in DOS and how you can do it in different ways, I just wanted to make a video about something because, in my opinion, there's not a lot of information online about it, or at least not a lot of concise and clear information. And it's something very simple. It's just about how to write into the computer memory. And those of you who've been using computers for many decades, ever since the Apple II Commodore 64 era, you might remember that the Apple II and Commodore 64 came with built-in commands in their BASIC system. They had like a basic interpreter built into their ROMs, and they had peek and poke commands. And peek let you look directly at any memory address. It would show you exactly what was in a particular memory address. And poke actually let you poke something into that memory address. It would let you write directly into a memory address. And both these are functions that have not seen widespread use in many years because most people don't care these days about what exactly is in the computer memory. They work in higher level ways, which is okay for if that's what you want to do. But I think it's kind of unfortunate that people sort of have forgotten or maybe never learned in the first place how to actually see what's in the computer memory and interact with it directly. So in this video, I wanted to do two things. One, I wanted to write directly to the memory, but as a sort of a byproduct of that, I wanted to be able to draw pixels on the screen because in VGA mode, in the venerable VGA mode 13, which was very popular among DOS games, the video memory, and in most other video modes as well, the video memory was just nothing more than just a location in the computer memory, and writing into the memory would cause pixels to be drawn on the screen. So I want to see how we can do that in three different languages. Actually, I wanted to make this video in three different languages. So let's go ahead and get started. Let's get started with the with probably in many ways the most direct way to do that, which is assembly language. Or at least when people start thinking about this stuff, they may first start thinking about assembly language because that's kind of the most direct way to do things. So what I'm going to do here is I'm in the A86 directory because I personally have always used A86 as an assembler just because it's smaller and simpler. There's not a lot of big setup that you have to do for it. It has a few quirks which we'll see in a minute, but let's go ahead and get started. Let's go ahead and create a file. I think I still have the FreeDOS editor in my root directory here. So I'll go ahead and say edit a file. Let's just call it drawpixel.assembler. We have to restrict ourselves to 8 characters because we are here in DOS, or DOSBox technically, but yeah. So, so we want to work in VGA mode, in VGA graphics mode, right? So what I'm going to do first is I'm going to go ahead and change the video mode. So in DOS, interrupt 10H, 10 hexadecimal is the interrupt for, actually not only in DOS and PCs, because this interrupt is not supplied by DOS, it's supplied by the BIOS. So from the BIOS, interrupt 10 lets you set video modes. But in order to use this, what you need to do is set AH and AL. So you set AH to 0 because that tells interrupt 10 that you want to set the video mode, and then you set AL to whatever video mode you want. For this video, I'm going to be using mode 13 hexadecimal because that is a very common video mode that was used by DOS games back in the day. It's 320 by 200 pixels, 256 colors. It's a pretty decent video mode, and it's easy to work with because each pixel on the screen is just one byte in memory. So the very first pixel, the upper leftmost pixel, is basically, I think it's just pixel 0. Then the pixel to the right of that is pixel 1. Then there's pixel 2 and 3 and 4 and so on. And then when you get to the end of the line, it just wraps around to the next line. So the first line would have 200 pixels in it. So I guess the last pixel is pixel 199 because they start from 0. And then just wraps around like that. So it's pretty easy, pretty straightforward to work with. And I'll just make a quick note. The above 3 lines just change to VGA video mode 13H. 320 by 200, 256 call, because I'm running out of space on this line. I can go off the end of the line, but I don't want. I want everything to be visible all at once without having stuff disappear off the side of the screen. So if you're really doing it in assembly language as we are, then basically you need to set the registers yourself, as we've already done with H and AL. So what you need to do is set the segment. Specifically here we're using the data segment. There are different segment registers in an x86 processor, but for the we actually want to set data. So we don't want to use the code segment, which sets where the code is running, or anything like that. We just want to use the data segment. So I'll set the data segment to the start of, well, VGA memory is the VGA screen memory starts at address A000. That's pretty easy to remember. That's the location where VGA screen memory starts. A86 has this quirk where it doesn't like memory locations to start with a letter, so I need to put 0A00, which is the same, because any number that starts with 0 is the same as the number without the 0, but it's just kind of a quirk of A86 that it wants a... If your address starts with A, B, C, D, E, or F, then you need to put a 0 before that to let it know that that's a number. And I'll just put H at the end, even though it's pretty unambiguous that this is a hexadecimal number because it has an A in it, because I think it assumes decimal numbers if there's no A, B, C, D, E, or F, but if there's an A in it, that's pretty obvious it has to be a hexadecimal number, but just for consistency's sake, I'll put an H there just so it knows that that's hexadecimal, even though I think it'll assume that. Okay, so we've set our segment, we've set the data segment where we want to write data, and now all we have to do is just write data to it with another move instruction. So what you have to do with A86, well, I guess with assembly in general, you have to specify, is this a byte or a word move? A word is, I guess, generally 2 bytes, like 16 bits, but we're just doing 8 bits here, 1 byte, because in VGA mode 13, 1 screen pixel is 1 byte of the screen memory. So in A86, the way you do that is you just type the letter B. So W would be a word move, and then B is a byte move. So I think other assemblers might have other syntaxes. Like some assemblers might have you write the whole word, like you'd have to write move byte, but with A86 you just type move B, and then in crud. I can't. Using a German keyboard here, so I can't. Crud. Okay, hold on. Okay, let's do this then. Let's go ahead and save this. It's nice that it asks me for the file name, even though I explicitly gave it a file name. Drawpixel.asm. There we go. Okay, what I'll have to do then here, let me kick out of this real quick and just say keyboard US. There we go. Because I will need to be able to do stuff like put down. There we go. Now I can put square brackets here. So so here we just specify the offset, the offset that we want to write to. Let's go ahead and use, for this video, I'll just use offset 200 hexadecimal. For no other reason, it's just an arbitrary number. We could use 100, we could use 1. Let's just do 200, why not? So I'll just put 200 and then comma and then the value that we want to write. So the value that we write here can be any number from 0 to 255. It's just the color, the actual value that you write into that memory. So this value here, this is the location on the screen, the location in memory that you write to. This determines where on the screen the pixel is. And then here we put the actual value that we want to write, and this is going to be the color. So for these exercises, I typically use 44 hexadecimal because 44 is yellow. And it's kind of a bright color, so it's relatively easy to see. And it's kind of distinct because if you see yellow there, then it's clear it's not just like a fluky white pixel or something. It's bright and it's really distinct because yellow is not used too much in DOS otherwise. So that's it. We should already be done here. And now we just need to end the program. And in assembly language, the way you do that is you move 4C00 hexadecimal into AX, and then you call interrupt 21 in DOS. This is how you do it in DOS because interrupt 21 is supplied by DOS and not by the BIOS. So, okay, let's go ahead and save this. Did that save? There we go. Okay, I think that should have saved. All right, so that's it. That should be our program. So let's go ahead and just run that now. A86 draw pixel.asm. Okay, I'm not getting any errors, so that's a good start. If I say draw pixel, it's created drawpixel.com. So if I run drawpixel now, hey, check it out. We have a pixel up there. So it's kind of in the middle of the, so that's location 200 on the screen. And if I wanted to shift it around, I could specify a different number than 200. But yeah, let's just, let's go and leave it at that for now because, oh, I was trying to think, why is it, yeah, sorry, earlier I said that it's 200 pixels wide. No, sorry, this mode is 200 pixels tall. It's 320 pixels wide. That's yeah, I was just trying to think, wait, did I get that right? No, I didn't. It's 320 pixels wide. So the last pixel on the screen then is 319 in decimal, and it's whatever in hexadecimal, it's whatever that is in hexadecimal, but there you go. Okay, so that's how you do it in assembly language. Pretty straightforward. So I'll go ahead and clear the screen. And, oh, now I have to figure out where are these, I have to figure out where these keys are with an English keyboard. Actually, I guess I can just use up arrow, can't I? Yeah, just use, there we go, just do that. So there you go. So this is basically it. This is how you do it in assembly language. It's pretty straightforward. You set the video mode if you need to using these 3 lines. You need to set the segment, and you do that using the DS register because that's the data segment. That's where you store what segment you're working with or where the data is that you're working with. And then you just specify a byte move into whatever offset you want of whatever color value you want. That's it. That's how you write to the screen. So this is how you write to memory in general, and specifically in this case, this is how you write to VGA screen memory to write a pixel. So that's it, done. Assembly language, pretty straightforward. No big surprises there. Nothing really special that you need to know about it, I guess, that you probably wouldn't already know if you've been programming in assembly language before. Okay, so from there, let's move on to BASIC. And of course, I'm going to go ahead and use Quick Basic 4.5 because this is sort of the quintessential BASIC environment for DOS. It's really a great environment. I mean, Microsoft did great things back in the day. I'm not a fan of Microsoft's more recent work, but this Quick Basic is a great product. It's really cool stuff. And the thing that we've just done in assembly language is actually really easy to do in BASIC. BASIC tends to get a lot of criticism because it's so high level that it's difficult to do anything with it. But QBasic and QuickBasic, Microsoft really did a nice thing with it because it gives you the best of both worlds. It gives you the ability to do really low-level stuff. So for example, setting the screen mode, before we had to set 2 registers and then call an interrupt. In BASIC, in QuickBasic and in QBasic, there is just a statement called screen. That's it. You just write screen 13, and that's it. Done. You set VGA mode 13. If we run this now, I'm just going to go ahead and run it, and you don't see any graphics, obviously, because we haven't drawn any graphics, but you can see at the bottom the text is that big chunky text that you see in VGA mode 13. So that's it. We've already set the mode. Now what we need to do is set the segment. Again, you want to specify your data segment, right? So in BASIC, you do that with def seg, define segment. And then, where's the equal sign with this keyboard now? There we go. And what you do is you say and H for hexadecimal, and then, again, A000. So that's the segment. So and H just means this is a hexadecimal number, and then A000 is the memory segment that we are working with. That's the defined segment. And now you use the all-magical, all-powerful, venerable poke statement. So you say do a poke, and again you do and H to specify a hexadecimal number. You could actually specify a decimal number. It doesn't matter. It would just be a different location. If I say and H200, this is hexadecimal location 200. If I just say 200, it assumes a decimal number, and it will work. It will just go somewhere else. So for consistency's sake, let's let's say hexadecimal 200. And then again, we just need to specify the value. And I'll say again, let's do a hexadecimal 44, because that hexadecimal 44 is that yellow that we saw before. So that's it. Let's run this. And there you go. You can see there's a yellow pixel there. It's the same color. It's in the same place as in the previous program. That's it. This is how you do it in QBasic and QuickBasic. Set the screen mode with just one line. Define your segment. Poke it. Done. Now, you know, a lot of people will say, well, that's too simple. You're covering up a lot of what happens. You're concealing many of the functions from the programmer. Yeah, you are. And, you know, there's a time and a place for stuff like this, I think. Sometimes you really want to understand what's going on. I'm all for understanding. Believe me, I want to understand, and I want people to be able to understand what's actually going on and what they're doing. But, you know, to be fair, there are times when you just want to do something really simple like this, and you don't want to see all the background stuff. You don't want to see what the registers are getting set to. You don't want to see which interrupts are running. You really just want to say, write this into that. Done. Boom. So a lot of people dislike BASIC for various reasons. I mean, there might be reasons for that, but BASIC is actually quite powerful. I mean, there's a lot of great stuff that people have done with BASIC. There's a whole sort of, well, I say there is, maybe it's more accurate to say there was a whole sort of underground community of people writing really impressive games in BASIC, like in QuickBasic for DOS, which, you know, were kind of on the level of, you know, pretty much professional quality games. And they did it with a lot of this sort of low-level stuff. Like you can do direct memory reads and writes in QBasic. You can call different, I think you can call different interrupts and things like that. So, you know, it's pretty powerful. It's not for everything. It's not the best language for everything, but for a lot of stuff, QuickBasic is actually a really great environment. So, you know, I think there's a time and a place for stuff like this. So that's it. That's how you do it in BASIC. It's really simple. All right, let's go ahead and quit. No, I don't need to save that. So moving on. Ideally, I might want to talk a little bit about Pascal, but it's kind of too bad that Pascal has kind of disappeared from the world. Because back in the days, you know, remember in the DOS days, Pascal was kind of a big deal. There was Borland Turbo Pascal, and a lot of people were writing games and other software in Pascal. It was a decent language. I never got that much into Pascal myself. But it wasn't a bad language, but it's just sort of fallen by the wayside, and you don't see a lot of stuff being done in it today. I guess there's not much being done in BASIC today either, but BASIC is at least a language which most people have used. Maybe not younger people today, maybe not people who are like 20 years old today, but people who were using computers 40 years ago will have had almost certainly some exposure to BASIC because it was built into the Apple II and Commodore 64, and it was still widely used in the DOS era because QBasic came with DOS 5. So, you know, there's definitely a community of BASIC programmers, whereas Pascal programmers, I'm sure there's a community of them. I'm not really aware of one. You just don't really hear from them or see them that much. It's really, as far as I can tell, it's pretty much disappeared, which is unfortunate. But I'm going to skip over Pascal for this video, and instead I'll just go directly to C. So for this, I'm going to use Borland's Turbo C. I think from here I need to go to the bin directory and then TC, right? Yeah. So this is, yeah, Borland Turbo C++ version 3. And again, Borland also made Turbo Pascal, which was widely used back in the DOS days, but we will sadly not be seeing that in this video, for better or for worse. Now, doing stuff like this in C is a little bit funny because C is not really made for stuff like what we're doing here. C is not made to do direct memory reads and writes. You can do it, but it's more complicated. Most C compilers will not have just a simple peek or poke statement. You'll need to do some funny stuff. So, you know, which makes sense because C is meant to be portable. It's designed to be, you know, to kind of save you from having to do those low-level tricks. So there's a lot of stuff in C that you can do, but it is kind of not really, the language is not made for it. So what I'm going to go and show you is how you can do it with the understanding that we're doing something a bit outside the scope of what C was originally made for. But you can do it, and once you figure out how to do it, it's not difficult to use it. In fact, it's probably easier to use it than in assembly language. So what I'm going to start with here in C, as with so many other things, I'm going to start with a pointer. And you probably know, I mean, if you're a programmer, you know that a pointer is a variable that contains a memory address. So instead of the, so typically you might have a variable, like if I have an integer variable, call it a, let's say, then I can say a equals, if I can find the equals sign now, there we go, a equals 10, for example. Why not? There we go, that's it. Now I've got a variable called a, and it's 10. But when you make a pointer in C, let's make a character pointer. The reason I want to use a character pointer is because character is the only real variable type in C that is 8 bytes. Even in integers, the regular integer is 8 bytes, 8 bits. It's one, a character is 1 byte, it's 8 bits, which again is the size of 1 pixel on the screen. An integer in Turbo C, I believe, is 16 bits, so that's 2 bytes. So if we started using an integer variable here, we would actually then be changing 2 pixels on the screen at once, which we don't want to do. We want to address just 1 pixel at a time. So I'm using a character value, which is meant for characters, like, letters like A, B, C, or numbers like 1, 2, or 3, but it can also be used to address single bytes because it's the only, I believe it's the only variable type that's 8 bits in size. So we're going to use a character, like a char, a character type here. Now, if I say character asterisk and then call it whatever, I mean, I don't know, call it Kermit. What I've done here now is I've created a pointer here called Kermit. And now if I do something like, if I say Kermit equals, again, let's say 10, what I've done here now, I haven't changed the value of Kermit to 10 per se, because Kermit is a pointer. What I'm saying is Kermit points to memory value 10. It points to byte 10 in the computer's memory. So we do not want to do this. I'm going to go ahead and comment that out and say this would change the memory address pointed to. Do not do this. What we want to do instead in C, the way that you dereference pointers in C, and again, if you're a programmer, you probably know all this already, but I'm just saying it as a review because, I forget a lot of details like this. I forget the exact syntax of things like this. You might forget as well with time. So the way you dereference a pointer is you use an asterisk before the pointer name. And now if you say Kermit equals 10, this is now correct. This changes the value in the memory byte. So there you go. So this leaves the memory address unchanged, but it changes the actual value in that memory address that you're pointing to. So I'll just get this out of here for a second. We don't need this. How do I delete this? Can I not? Okay, it looks like the editor here doesn't let me actually just, okay, fine. So there you go. So we've got a character pointer called Kermit, and then with a line like this, by proceeding with an asterisk, we can actually change the memory, the value of the memory in that memory location. But if you do it without an asterisk, then you actually change the memory address that it's pointing to. So far so good, right? Okay. So what we want to do here is we want to go a step further for our application today. We want to specifically specify an unsigned car, or unsigned character. Now, what does that mean? That means it can only be positive. So a signed variable means it can have a plus or a minus sign. It's an integer, so it can have a positive or a negative value. An unsigned number means it's always positive. So there's no -1, -2. It's always 0 or above 0. It can never be below 0. So the range for signed cars, for signed character values, is -128 to 127, which we don't want. We don't need that. We're not going to have negative values here. So unsigned cars go from 0 to 255. So that's what we want. So that's why I specified an unsigned car. That's exactly what we want here. Okay, so far we have an unsigned character pointer variable called Kermit. What else do we need? In C, what you want to do here is specify a so-called far pointer. Now, typically what'll happen is, when you run a program, the program will be in some random segment in memory. It doesn't really matter where. The operating system just kind of dumps it in whatever segment is available. And so if I say something, again, if I say something like this, Kermit equals 10, it will just put Kermit. It's going to put this somewhere in memory, wherever memory is free. But for our application here, we need to specifically write to segment A00. Sorry, A000 in memory, because again, that's where the VGA memory is. So specifically for this application, what I'm going to go ahead and do is add the word far here. Now, this will not work in a lot of C compilers today. Many C compilers today will block this. Either they don't understand far, or they'll just flat out block it and say you can't do that. Because what a far pointer is in C, a far pointer is a complete memory address. It specifies the segment and the offset of computer memory. That means you're basically, if you use far pointers, that's giving you access to the whole memory in the entire computer. Most C pointers and things like that by default are near pointers, and near pointers just point to an offset in your current segment. So you're confined to whatever segment the operating system gives you, and then within that segment you can write to whatever offset you want. That segment belongs to this program. So you can write, you use a near pointer to write to an offset within your current segment. But we specifically need to specify an exact, actual, physical memory address in the computer, and for that we have to use a far pointer, because the far pointer points to a complete address, segment, and offset. Which again, I'm pretty sure Windows will not let you do this. If you try this on Windows today, Windows is going to block it and say, can't do that, we won't let you use far pointers. But back in DOS, you could still use far pointers. This is a common thing. We're going to specify an actual memory address, like the whole thing. So here we go. So now we've got an unsigned character pointer, which is a far pointer, and it's called Kermit. We call it whatever. I don't really care what you call it, doesn't matter. So that's it. That's what we're going to use to do a direct write to VGA memory. And I'm going to show you a little trick. I'm going to show you kind of a wacky little trick. I'm going to write a really wacky, funky, crazy line now. I'm going to try to explain it as I go. So we're going to take, once again, an unsigned character pointer that's a far pointer. And I'm going to put the whole thing in parentheses. And instead of specifying a variable name, instead of creating a variable that's a pointer, what you can do here is just write the memory address directly. So instead of saying, Kermit, and then saying Kermit equals something, I'm literally going to put right here the memory address. I'm going to start with 0x to specify that it's hexadecimal, and then here I'm going to write A000. And I need to finish this because that's the segment. I also need, because this is a far pointer, I need to write the offset as well. So we've been using location 200 in the VGA memory, so let's continue with that pattern. So we're using, byte 200 of the VGA video memory here. And then we can just say equals, and again, I'll say 0x to specify hexadecimal number. And we've been using 44, which is yellow, so let's continue with that. Done. And what else? Don't forget, put an asterisk here at the beginning to dereference this, because otherwise, if you don't put the asterisk here, if you just do this, you're saying that A0000200 is equal to 44, which is kind of impossible because they're different numbers. But if you put the asterisk here, then that means set the value of the of that memory byte, whatever is in that memory byte that I'm pointing to here, set the value of that byte to be 44. And that's it. This is the line that will do it. With this one line, you can do what we've done in previous programs. So you don't need to separately specify a segment because it's part of your pointer here. So you're specifying the whole address here and setting it to this value in one line. Now, you need a little bit of setup here. I'm going to delete this stuff here. Actually, how do I? There we go. Clear. You do need to do a little bit of setup. So I'm going to do some funny stuff which is specific to Turbo C. I don't know how you do this or if you do this in other compilers, but what we need to do first of all is set the registers. We need to set VGA mode 13. We've not done that yet, so we need to actually change to the correct video mode before we can do anything else. What Turbo C does for this is it uses something called a union of the type regs for registers, for CPU registers. I'm just going to go through this kind of quickly. I don't want to explain the whole thing because this is something very specific to Turbo C. It's not something that you'd use in any other compiler, I don't think. Other compilers do this differently. But basically, I've got something called regs now. This is a data structure here that I have. So I'm going to say regs.h.ah. This is the CPU register AH. I'm going to say again it equals 0 because that tells interrupt 10 to change the video mode. Now I can say regs HAL, and again use this to specify which video mode you want. So you type 0x13 for hexadecimal mode 13, that's VGA mode 13. And then in Turbo C there is a function called int86, which calls a software interrupt in your environment. So here we use 0x10 to specify that you want to call interrupt 10. And funny thing that Turbo C does is you need to specify the register structure twice. What I'm going to do here is say and regs, comma, and regs. If you don't understand exactly what this is, don't worry about it too much. Basically, you can define a register's structure here, and then you can call different software interrupts with different predefined register structures. So you don't need to specify them on the fly. You can have them kind of prepared in advance and then give register structures to the interrupts as they're being called, which is kind of a cool idea, I guess. I mean, this is sort of typical of writing in a higher level language like C. Like there's more stuff you can do, but there's also more setup that you need for it. So these lines here now, these 4 lines that I've got here, that's going to set VGA mode 13. And again, if you don't understand this completely, don't worry about it too much. This is something specific to Turbo C. It's not something that you really need to understand at this point. What I do also need to do is include, in Turbo C, it's called, where is it? BIOS.h, which is needed for the regs structure. And because this is C, what I also want to do is not forget to specify a main function. And I know main is not supposed to be void, it's supposed to be an interrupt, but I like setting it to be void because I'm not going to return anything with it. Why do I need to set it as an interrupt if I don't want to return an interrupt with it? So I know that some people say void main is not valid syntax, it's invalid, it violates whatever C standard. I know it does, but it works. It works for what we're doing here. If it makes you happy, then do it with an interrupt main, integer. Do int main, integer main instead of void main. But this will work, so I'll do it like this. So let's go ahead and hit F9 for make. Okay, no errors. That's good. Oh, it made it no name 00, but that's fine. Okay, can I run this? I don't think I can. Hold on here. Run. There we go. Run. Yeah, it's kind of stupid. It runs it, but then it returns. It doesn't wait. QBasic by default waits for you to press a key when the program is done before it returns you to the environment here, but Turbo C doesn't. It just runs it and then brings you back here, so you can't actually see what it did. So I'm going to quit. Yeah, let's save that for a second because we'll want to come. Yeah, sure. Okay, why not? Let's just leave it at no name. Okay, so if I run no name now, yeah, there we go. It works. It drew 1 pixel. So, okay, so let's go ahead and run Turbo C again. And so yeah, this works. This works for setting this memory location here to this value. And all this stuff here, this is not necessary. I just put this here because because we're doing something with the video, I want it to be in the right video mode. But these 4 lines just set the video mode. But if you're not doing something specifically with video, literally this line here is enough to just do a direct memory write to a direct memory location in your computer's memory in C. So that's kind of cool. For this application specifically, what I'm going to do, just as another kind of a neat trick, I'm going to go ahead and I'm going to go ahead and cut this here, paste it up here, and I'm so used to, I've been so spoiled by Windows, Control X, Control C, Control V. See the shortcuts that they had used back in the day? Shift Delete to copy something, Control Insert. Imagine using Control Insert to copy something. Wow, some things have really changed. Okay, so I'm going to define this here now as a variable. So what I'm going to go ahead and do is say, we're not going to set it to 44 yet. We're not going to set anything to 44. What I'm going to go ahead and do is say I have an unsigned var character pointer, and I'm going to call it VGA space. And I will say that this pointer equals, and then I will set it to, not to 200, but to just a 0000000. With this line now, I've declared that I have a an unsigned 1-byte pointer. It's a var pointer. Call it VGA space. That's the name that we can use from now on. And where does it point to? It points to, and then I've specified a 0000000 as an unsigned var 1-byte pointer. What does this get me? What's the point? What have I achieved with this? Well, now, if I want to write a bunch of stuff into memory, I can just say VGA space, and I will need to specify the offset because this is now basically an array. It works like an array. So in square brackets, I'll need to write the location. So again, let's say hexadecimal 200 equals hexadecimal 44. And now if we make this and quit and save that. Yeah, you can, yes, overwrite it, that's fine. Okay. And now if I run no name again, it does the same thing, okay? It does the same thing that we already saw. So that in itself is not too incredibly impressive. But if I want to write a second pixel, instead of having to go through some huge song and dance, I can just say, make another statement and say VGA space, let's say now 400 hexadecimal. VGA space 400 equals, let's use a different color. Let's say color is, I don't know, 64. Actually, I don't know what color this is going to be because I don't remember the different color values, like the whole color palette for mode 13. But let's just randomly try writing a different color somewhere else and see what happens. So let's go ahead and make that. Done. Quit. Yes, save, yes, overwrite. And now if I run no name, there you go. Now I've got another pixel down there. It's like looks like a light blue kind of cyan color over there on the left. So that's hexadecimal location 400. So what you can see here, if we go back into our program now, again, this is kind of typical of writing in higher level languages like C. There's more setup that you have to do. Like I've got obviously a lot more text here than I had in BASIC and in assembly language. But I have the advantage now that if I want to write stuff into VGA memory, if I want to just dump pixels onto the screen, all I have to do is say VGA space, location on the screen, color value, boom, done. I don't need to worry about anything else. I've got a pointer called VGA space that points to that memory location, and I can just call it by name now whenever I want to in the future. That's it. So I don't need to worry about where it is or what type it is or anything. I just say, just put this pixel color number in that memory location. Done. So yeah, again, advantages and disadvantages. Each of these approaches that you've seen today, we've seen how to do this in assembly language, we've seen how to do it in BASIC, we've seen how to do it in C. And obviously all of these have advantages and disadvantages. Some things are easier, some things are harder. Sometimes you need a lot more text. You need more text to do the same thing, but then the advantage of that is you have more flexibility. Other times you just want to do something. You just want to do something with 1 or 2 lines and be done and say, okay, I've finished it. I don't care about the details. I just want to do it with like 2 or 3 lines of code. That's okay too. It's really dependent on your application and how you want to do it. So yeah, there you go. That is how to do a direct memory write in assembly language basic in C, and specifically in this case, the application of how to do that to make a pixel on your screen. So I think that's all. Thanks for watching, everyone. Hope that this was interesting and enjoyable. For me, this stuff is actually a lot of fun. I'm sure some people look at this and say, "What that's incredibly boring," but I find this stuff really fascinating, and hope that you did too. And whether you did or didn't, thanks for watching, and I will talk to you folks later. Bye bye for now.